there are two architectures that we talked about. So we would want to take up one of those papers, that is the Gauss-CNN paper, where they tend to go ahead and talk about what kind of models that they have used. They tend to go ahead and use with respect to whatever the data that you would be giving it over there. So that is something that's very important. In this case, the model architecture contains an CNN model, and the this model predicts two things. One is it predicts the length of stay, and the other thing it predicts is the readmission risk over there. So these are the two things that the model has been designed to work on. So one thing that you need to understand about this design is, so if any one breaks, everything breaks, right? So that's the kind of again that we have in this case over there. And when you talk about the second paper, that is from NYU Tron. So essentially, in the previous experiment, it was a discriminative model. So in this case, it is going to be again something like very compute power, right? So it would require you that, okay, so if you want to go and then be more complicated, so you can definitely use some of the neural networks that are available out there, right? And now, since now that you are completely clear about what exactly is the this one and then everything, so now you would be able to go and then cross-validate, right? So which means normally when data scientists, when they have to train a model, what do they normally do is they start with respect to very simple that is available. What do I mean is, so they try to go and then take your data out there, clean that particular data out there. So that is something that is very important when you work with respect to your training strategies. Okay, so if you could look at the performance model of the Gauss-CNN model, so this is one of the industry example that I shared with you. So this model is something that can predict the multi-disease generalizability over there, right? So some of the top features that the model thinks it is the age, the glucose control, and comorbidities, right? So, and again, when you talk about these kind of models, usually the compliances, they have to prove it along with the suitable proof over there. So that is very important when training your model over there. Similarly, when you talk about the Gauss-CNN model, so that was something that was trained on 1,085 patients, right? So during the COVID-19 process, so that would help the particular clinicians to identify, hey, how much of self-attention is something that might be pretty much required over there, right? So that's something that's very important that you need to understand it. And one more thing that I usually tell you is, one of the main important things that is important is whether whatever the models that we tend to go and use it, right? So whatever the output that the model gives, it should be predictable. It should not be able to change any of these things over there or add anything hallucinations. So that is something that we would have to take a look at it, right? So the other model that we have is the NYU Tron. So NYU Tron is something, the model that is being used in two places. One is to identify the operation risk, and the other is to identify the operational this one or that, right? Operational data, which means the model will tell you that how long does he have to stay in the offer bed, and then so on and then so forth. So one of the main successes for your particular model to be successful in the healthcare industry is that it should be integrated within the EHR workflow over there. In this case, if you could look at in the right side, so normally instead of having these applications as a standalone applications, it would be very helpful if you could have it as part of your note itself. Whenever you try to pull up your note in the paper over there, so there you would be able to see that in the EHR documentation, the explanation. Why does the model think that this person is saying that this should be calcium or that, right? So something like that. And one thing that you might be wondering until now is, okay, we talked about the data, we talked about the types of model, we talked about so many things. So one thing that you might be wondering is, how frequently does these models get updated? So one thing that you might want to understand about these models is they are all log models, which means that we barely have any space to like retrain a model. So the retrainer happens only on this one, right? So on a monthly basis or a half yearly basis or that. So training it daily or weekly would not be such a great idea. So this exercise is something that you would do it when you try to grow this thing so that. So that is something that's important. And whenever we want to trigger the model retraining, so we either train it in batches or we try to train it in real time. That is, I can try to take the transcript and then try to talk about that. So one thing that you would want to understand, how do you, whenever we try to take a model and then put it into production, the kind of this one is something that keeps on changing over there, right? So that makes us to understand that, okay, so if a person is talking about something, let him that finish it off over there. So that's the key in this case over there, right? So the simple one is also telling you the same thing. So that's something that we need to go ahead and handle it. The other thing that we need to talk about is the MLOps team, which is responsible for you to everything over there. So we try to talk about the performance of the model and then everything. So one thing that we have is how do you monitor these models over there, right? So there are various tools that are available to monitor these models, right? So we have different kinds of tools like Grafana and then CloudWatch and then other things that can help us to identify the problem and report back over there. So that is what is the use case that we have with respect to the models that are there in the production of that. Okay. So then we would want to talk about, okay, so we did talk about the model. So we did talk about what kind of data that goes in and then other things. But what we did not talk about is, so what makes a particular project successful, right? So what are the things that drives the successfulness, right? So one thing is whatever the data pipeline that we might have built, that is something that we should be using it. So then you have to design that whenever we try to talk about these kind of systems, so these kind of systems cannot be built on its own, right? So there has to be some clinical help. Something like the SME should have been a clinician who completely knows about this solution or that, right? So the next thing is it should be easily be integrated into the workflow. It should not look something like odd, right? So it should be something that should be present along with the this one or that, right? So, and one of the most important things that we should be remembering is whatever the output that the model gives, it should be explainable in nature or that, which means the model, when a model gives you a certain input, what is the cost for that? That is something that's very important. Since we were talking about the successes of the model, so we can also talk about, hey, not again, what kind of tools are we using for explainability? So it can be anything at all, right? So that's the whole idea about that. So when you talk about the barriers, one kind of barrier that we see is, okay, whatever the solution that we have developed it is not easily integratable, right? So that is something that would be taken care of. The other thing is people would face is the model drift. What if the concept for identifying which model to use when? What will happen if you try to mess up on that? So these are some of the common barriers that we have whenever we want to go and then train our model, guys. Okay, so you might be wondering that, hey, what is the use of us sharing the different kinds of use cases, right? So one good lessons that we were able to understand or talk about is in this particular system is they wanted just the this one, right? So just the data order so that it could be useful for us to parse and then work on that. Along with that, we do have the other lessons. One is definitely the workflow fit. So this is the one of the important thing that the industry was able to identify is, so she forgot this one, right? So one of the failed things for this particular model is definitely this one AUC score. Then the data should be complete or that you should not have bits and pieces, otherwise the model would get hallucinated over that, right? So it can give you wrong answers in that case. So that's why whatever the data that you have, so that is something that you will have to change it in a regular basis or that. So where are we heading towards all of these things, right? So going forward, we would want to go and implement everything as part of your GenAI, right? So GenAI should be able to give out the exact same reasons. So along with that, we want to build a model that can take various kinds of input, right? So that can take they can take anything that you want. So they can go and use any kind of model. So that is where we are going with respect to this one, right? So the other thing that we are doing is the federated learning. See, normally nowadays, what these health institutions they ask is they would want to understand that, okay, is there a way where we could use that to go and then train these particular models over there? So that is very, very important out there, right? So these are the future trends that is coming on your way out there. So just to summarize on the topics that we talked until now. So when it comes to the cost and the sales, so definitely we are talking about the sales force. And one thing that we have been emphasized on the point is, so the this one should be completely agreed, right? So they should be able to tell you that, okay, so this is something that has been covered it up over there, right? So the next thing that we is looking at in the summary that we talked about is the similar kind of use cases, right? So whatever the use case that we have, it's similar kind of use cases that we are going to have it in this case over there. And the very, very main thing that we would want to talk about, and which I've emphasized enough, is the combination of these two over there. So this is something that's very, very important. So let me know if you have any questions, guys. I think that's pretty much it. I've covered all the topics that has been planned for our today's session. Let me open up the forum for you guys to ask questions. I hope I have not gone in a very fast pace, guys. Can you give an example of federated learning? So if a very simple example, if I can give you about federated learning is, if you have used any Android phone, in your Android phone, you use your Google keypad, right? So that Google keypad is something that trains on your device itself. It doesn't have to train on a different system. When we talk about federated learning, which means the model training process happens within your system itself. Backend would not be able to help you much. Yeah, great, Marian. Other questions, guys? More data, such as zip codes. Yes, zip codes and then other things, right? So more the data. So just having more data is not sufficient. It should be from different regions of the data, right? So if you have all the data together, we could have, you know, like went ahead and then if you have all the data, we could train the particular model with respect to this data so that everyone would be able to get that. That's the idea. Any other questions, guys? Great, Marian. I'll just wait for one more minute, guys, for you guys to ask any questions. No questions? You were fast for me. The two papers that we gave about the example is, we were talking about what were the two models, why so what kind of features did those models work, and why did we what are the outcomes from those particular models, or that what did the scores look like. So that's what we were talking about, and the architecture that these models used. One of the model used the architecture of an CNN, and the other model used the architecture of an LLM. If you felt that it was fast, Sonal, you could have stopped me, right? So I thought that everyone felt that I was very slow, so I just picked up a little bit pace. But if you felt that it was fast, I could have slowed down if you'd have stopped me. Do you want me to brief on those two papers again, Sonal? Sure. Okay. Let's go back. Okay, so there are these two papers that we were talking about in this case. So one is you have your Gauss-CNN model, and the other is your NYU-Tron, right? So this Gauss-CNN model, so if you could look at the architecture for this Gauss-CNN model, underlying is a convolutional neural network. So when you talk about the kind of features that these models used was with mostly with respect to your clinical features and the long range pattern features over there. And this model is something that predicted two things. One is it predicted the length of stay and it predicted the readmission risk score. The other model, on the other hand, is a generative model, right? So it's a large language model. Mostly it has been trained on millions of unstructured nodes. So since it's a very complicated model, it's possible for this particular model to predict more, which means it can predict, just a single model can predict what is the in-hospital mortality, what is the comorbidity index, what is the 30-day all-cause readmission score, the length of the stay, and the insurance denial. And then we talked about what is the performance of these models, right? So how these models have been tested and what is the performance. So if you could look into Gauss-CNN, so this was something that has been trained on 101K patient records. And when you talk about the top features was, so the prior length of stay, the glucose control, and comorbidities were something of the very use in this case. So that the same way, if you could look into this Gaussian model was something that was used to go and then identify if there is something like a search that is required over there. So similarly, when you talk about the emphasis of this model was with respect to the explainability over there. One thing that this model intended to build was to make sure that whatever the details that we talk about, it exists. So that's the model about. The other model, when we talk about NYU-Tron, so this is something that not only helps the clinicians, but also the operational task. For example, how long the patient will stay in the hospital, how likely is the patient's insurance claim to be denied, which is very, very important, right? So once they apply for a claim, it will take a lot of time. So this is something that's very, very important in this case. So these are the two models that we talked about, Sonal. Does that make sense? Any questions? If there is any other part that you want me to repeat, guys, I can definitely do that. We have a lot of time. Any other questions, anyone? Great, someone. Summarize the workflow. Yes, the summarize is, let's go back. What is the summarization is, see, if you tend to use very simple models, the thing is you will get, the model's performance will not be so great. But if you tend to use more complicated models, you'll get a higher performance of the model or that. But at the same time as well, you would be able to, you will need a lot of compute power. So whenever we try to talk about these models in most of the use cases that we saw is, whatever the explainability part that we have, it has to be integrated within your node. So mostly your model should be integrated within your workflow itself and then not put up as a separate system. The most important thing that matters to improve these models is the provider's feedback. Without provider's feedback, it would not be possible to go then fix this model over there. So those are some of the things that we saw in these slides. Does that help, Sonal? Issue with patients being readmitted outside the hospital system or geographic Asia. Unclear how to overcome this flaw. Thoughts? See, whether they are getting readmitted outside an hospital. So readmission outside an hospital, so that's still a problem, right? So which means, so if you are using an EHR document, this is something that gets recorded, which means you are getting readmitted to a different hospital, maybe for two reasons. One is you might have moved, or you might feel that, okay, you did not get quality care over there, right? So those two things is something that has to be taken care of, right? So the normal model should be able to work it out. But the thing is how and where to prevent it. That's is what more important. Yes, more on the provider's feedback. Yes. Provider's feedback is, so say for example, whenever you try to talk, whenever a model gives you any output, right, Daniel, right? So the provider should be able to tell that, yes, this is something I felt it is useful for me. The provider should tell you that, okay, so whatever the model gave the input saying that, hey, I looked into this features and gave me the output. So that's not really it, or that's really it. That was helpful. That was not helpful. That's the feedback that we're talking about. When discussing data quality, what if the data is missing are the key elements of this thing? For instance, missing data could actually be something that needs to be known or assessed in order to prevent the future readmissions. So it can be possible, Jamie, right? So whatever the data that might be missing, it can be possible with that. That's why before dropping off on any data, we do our analysis and then we train our models. So that's a valid point. We don't just drop off all the data that are 20% missing over there. See, when you talk about your healthcare records, not all the data will be missing. Some of the data might be missing because of this one or that. This it should be good. So the providers is the user of the model. Yes, mostly them, and the admin staff, clinical staff and the admin staff, both. Any other questions, guys? Okay, that was my concern. If you leave out data just because it's missing from a data set, then you could lose valuable insight. But I understand your explanation. Again, to be very honest, Jamie, so we don't really leave out any data because in medical, in EHR data, right? So not all the data might be filled up. Now, say for example, some of the lab results, a particular patient might never have gone through it, right? So that might turn out to be missing data, but it's actually not missing. It's just irrelevant. That's it. It's like somebody came in for a fever, and then for that particular person, you are doing an CT scan and an MRI scan. It would be unnecessary. It's how it is. Correct. Exactly. Yes. See, normally, whenever we want to train our model, right? So the model has to be trained using what we do is, let's assume that you have 100 rows of data. In this 100 rows of data, what do we normally do is we split it into three parts. So we split it into train, test, and validation. So the train data will be trained using all the patterns that is available, and the test data will be tested against it. So what really happens during this process is sometimes the model becomes overfitted. So that's why what people do is they take up this one of the validation data and then put it aside, and it will be only used when it is absolutely required over there, which means when you want to push the model to GA, that's where it will be tested with the validation data. Otherwise, until you fine tune the hyperparameters and then everything, you will only be working with train data and your test data out there. I hope it answers your question, Sonal. Any other questions? Any other questions, guys? Okay, so if you do not have any further questions, guys, I think we are good to close on our today's session. Thank you, everyone. See you all in our next session, guys. Have a great weekend.